Here we have the 2012 Relative Velocity question at noon. Ship A, 50 kilometers north of Ship B. A is 50 kilometers north of B. Ship A is traveling southwest at 24 route 2. Southwest will be along this direction here, which would make this angle 45, which would have the eye opposite that 45. B is going due west along here. This would also be 45 for A, so we could take our vector here for A, the velocity of A. Let's do it. It's going to be into the minus sector if it continues down in this direction. So minus 24 root 2. It will be the sine of 45, but it doesn't actually matter here. We could take this 45 and use the cos of it in the I direction. Minus 24 root 2 cos 45 in the j direction, which is going to be, the root 2's be 1 over root 2, to cancelling the root 2 on top, minus 24 in the I direction, minus 24 in the j direction for the velocity of A, and the velocity of B is due west at 17 kilometers an hour. So minus I direction, minus 17 in the I direction, plus 0 in the j direction. And in part 1 we're asked to find the velocity of B relative to A. Velocity of B relative to A is the velocity of B minus the velocity of A. So it's going to be minus 17 minus 24, so plus 24, so that's going to be 7 in the I direction. And we're just going to have 0 minus 24, so plus 24 in the j direction. And we're asked for the magnitude and the direction of the velocity. So the magnitude of the velocity of B relative to A, this works out evenly. It's going to be 25. 7 squared plus 24 squared is 625. So 25 kilometers an hour for the relative speed, and the direction is going to be, I'll just do a little sketch here. A, B. You can see the velocity is positive, and it's B relative to A, so we're going to leave B positive up in that direction. A, B. They were 50 apart. The shortest distance is going to be this one, along here, and the direction that it's going with a 7 in the I direction and a 24 in the j direction. And we are going to need this angle as well in the question, but this angle theta, the inverse tan of 24 over 7, is equal to 73.74 degrees, and that will be north of east. Yeah, that leaves the angle inside the triangle A. A is equal to 90 minus 73.74, which is 16.26 degrees for the angle A. Now, we're told that they can exchange signals when they're not more than 20 meters apart. So they're at 50. So I'll do a new diagram, but we're going to have a 20 in here. This dotted line would have to be 20 on both sides. So let's create a new diagram. So here we have them 50 apart. And here's the velocity of B relative to A. So there's my two 50s, my shortest distance. And here's my 20s. These two in here are 20. These two on the outside are 50. So we have to know these distances along here. So what have we got in this right angle triangle? Just take it out and draw it like this. This is this right angle triangle here. So my hypotenuse is 50. And my angle A inside here is 16.26. So we can definitely get both of these sides. Let's get x. So we could say that the sine of 16.26 is equal to x over 50. So put the 50 in front and do it in one step. So this works out to be 14.00014. So x is 14 kilometers. We may as well get y while we're at it. Y is equal to the square root of 50 squared minus 14 squared, which works out to be an even 48. Okay, so they can exchange signals. They are here, so they can exchange signals when it gets to here. So we have this distance from the bottom of the triangle. And this bottom of this triangle is the diagonal of 20. And this was x in here, which we got to be 14. So this one is the square root of 20 squared minus 14 squared. And the square root of 20 squared minus 14 squared is equal to 2 root 51 on a calculator. We'll decimalize it 14.2828. 14.2828. I'll take 4 decimals for now. So we have to go from here to here before they can exchange signals, and then they can exchange signals while they're between here and here. So that bottom distance along here is 48. So 48 minus the 14.2828 is 33 point, that will be 7172. And they're traveling at a speed. We got the magnitude, didn't work out to be an even 25. Divide that by 25, we get the time involved here. So this is distance on top, kilometers divided by speed, which will be time. So the time is 1.348688 hours. And to convert that to minutes, we're going to get 21 hour and 20.92 minutes. So 1 hour 21. So noon plus 1 hour 21 is 13:21. They can begin to exchange signals. And then, what was the last part? How long can they continue to exchange signals? So we need that length there, that double length. We actually have this one in here, don't we? So it's these two together, these two, they can exchange signals. So it was the 14.2828 times 2. That's going to be 2856.56. And they're going to 25 kilometers an hour. Gives 1.142624. And converting this into hours a minute, we get 1 hour. 8.55 minutes, so 1 hour 9 minutes.